First of all, thank you to Marcus and Stuart for inviting me back. I'm sure it's like a small thing for the uni does, but to me, it's a privilege to come back and talk about something that I'm obsessed with. The title of this talk is Digital Democracy and Polarisation, and the first part of that is really the focus of the talk, and then the second part is the finding of a paper that myself and Stuart worked on and managed to get published in the Journal of Computational Social Science. Bit of housekeeping. If you've got any questions, pause this as we go through. It's a little bit easier that way, and it's not a long talk, so yeah, there's plenty of time. So the question the problem that's really been bugging me for a while is, if we don't know how our local representatives vote, how are we supposed to hold them to account? And when I started doing the masters, it gave us a little bit of time to start thinking about that question. Now, if we went to Falmouth High Street and we start taking a random sample of different people, we found about 40% of those people will be able to know who their local representative is. Okay, let alone on what they voted or how they voted on the issue that we don't know what they last voted on, right? And so we called that sort of gap in information an information gap. And even though that's a social problem, I make the claim that it's the job of data scientists and entrepreneurs to try and visualize that data and try and close that gap. Okay, so that's the goal. I cannot figure out how to move through. Okay, this is the model itself, right? So I'm sort of skipping ahead, but I'm going to try and take us through the sort of the thinking and how we ended up with the paper. We start with the Parliament data, right? There's been 20 years, 2 decades of government transparency initiatives, and they've been putting all this data online, but they call it like thin, transparent information, right? It's data that's available for me and you to access, but someone like my nan isn't going to be able to get a hold of that data. So we've got the Parliament data, and then we're going to do a round of clustering. I'm going to bring thousands of data points down into a few sort of digestible clusters. Then I'm going to do a round of classification. So if I've got a cluster like immigration and borders, I need to know how does the vote impact that cluster? Does it tighten immigration and borders, or does it soften immigration and borders? So I'm going to do a round of classification, and then finally I can combine the clustering and the classification with the vote data and visualize it in a meaningful way. And that will hopefully start to make a little bit more sense as we work through. I'm really going to battle with this. Okay, the data that we're working with is it's coming from 2 points, right? You've got the vote data, which is useful because it pins down an MP's opinion at a given time. And it's also quantifiable, which is just gives us a nice thing to work with. And there's also a massive textual repository of every word spoken in the House of Parliament. And that is usually related to a specific division. That textual repository is called the Hansard, and there's a gap in the Hansard between 2004 and 2006. Before 2004, the data's there, but it's unformatted. You can't really use it. So that's fine. I'll take 2006 as my starting point, and we're going to go up to present day, which was 2023 at the time, and that's going to be my data set. Now, I said that I'm taking it from 2 different data sources, right? So I've got my Parliament data API, and I've got my Hansard Parliament website. But when in that date range, there's about 4,000 divisions, right, votes that took place. If I try and combine the data sets, I can only match about 2,600 divisions, right? And that's a problem. It's just sort of a data validation issue. But what I'm hoping is that as we work through this process, enough of that data survives that we get some kind of signal. At the end, when it's all said and done, at the end of the classification task, I went through 32,890,533 words. That doesn't really mean anything other than that, I'm dyslexic. That would have taken way too long for me to read personally. I couldn't have done this task without some kind of natural language processing technique. And I'm going to sort of come to the conclusion, and I'll guide you to it, that actually large language models are necessary to process that amount of information. Okay, so that's the data. So the first task is clustering, right? So I'm trying to I've got all these thousands of votes. Relax. I've never seen that before. I think I know what that's supposed to say, so I can get away with it in a minute, but we'll come to that issue in a minute. Okay, so the title itself, right? I'm going to try and cluster these things, and I'm going to do it based on the cluster, based on the title. The actual information that I've got, the textual data, 32 million words, is just too many words to use to try and cluster this information. So I'm going to take the title, and the title is cool because it's basically just a very signal-rich description of what the vote's about, right? So if I've got a vote illegal immigration bill, the word illegal immigration tells me a lot about what's going to be in that bill, right? And words like bill isn't going to tell me anything, so we're going to do a bit of pre-processing. We're going to get rid of stuff like bill, and I'm also going to remove anything after the semicolon. And the reason I'm going to do that is because anything after the semicolon is related to the type of division that's taking place and the specific niche amendment that's going on. There's a little bit of an issue there, okay? And the issue is that when we get to our classification task later on, you could have a bill that is a motion to propose a bill. You could have a motion to disagree with a bill. But you can also have a motion to disagree with an amendment to a bill. And this very subtle logic change means that if anybody that's doing NLP before, like, red flags are already going off, because if you've got massive textual data, but then very narrow, like the logic flips on just a couple words at the very end, it's going to be very difficult to classify. So we're going to come back to that problem in a minute. This is just a slide talking about the traditional NLP approaches, right? And the reason why I want to do traditional NLP, it's like a statistical method that I can just take my own bias out, right? LGBT rights might be important to me personally, but I don't actually know if it's going to be important to everybody in the populace. And the other thing is I don't know anything about politics, right? I do marketing. I'm now a data scientist, but I don't know anything about politics. So let's do a statistical method and then go from there. The first one is k-means, right? K-means is an awesome method. The problem with it was that it optimized around 550 clusters. Too many clusters. It doesn't mean anything, right? If you're trying to get from 1,000 down to 10, 11 clusters, 500 is too many. The second method was DBS scan. DBS scan, cool method. I could get it to optimize around 32 clusters. I think the minimum cluster value was about 2, epsilon was about 2.14, and you sort of optimized it. I could get it down to 32 clusters. But the problem is, with DBS scan, you start with a dimensional space, you extend the size of the group, and it sort of adds other groups in. At 32 clusters, one of the groups would expand and eat up all of the other titles, and it would basically ruin the process. So I left DBS scan, that's not going to work. This set of question marks is to do with hierarchical clustering, okay? And this was the most effective method, and we got down to 32 clusters again, but I managed to get all of them clustered in a neat way. The problem with that method is that you'd have, within groups, they wouldn't be similar enough, right? I'd have illegal immigration, I'd also have like migrating birds in one cluster, and then I'd also have like asylum seekers over here in a different cluster, because there wasn't a connection between the words, and basically the titles didn't contain enough information. Now I'm going to come back to a potential solution for that later on, but at this point I'm starting to panic. Stuart's telling me, don't worry, we'll figure it out. But I'm starting to think, like, does it really matter? Like, do the clusters actually matter? Like, it would be nice if I could do it in a statistical way, right? I could avoid sort of my own bias. But really, I just need to group these things. And so I'm starting to think large language models 3.5, ChatGPT 3.5 has just come out at the time. And large language models are still a statistical approach, but they've also been trained using RLHF, reinforcement learning with human feedback. And the benefit is that not only am I going to get clusters that are sort of have a statistical approach, but they're also going to be relevant and interesting to a human observer. And that's like a trivial bonus that a statistical approach NLP approach wouldn't have. So I'm still using the pre-processed titles, right? We're still doing a lot of engineering here. But I feed in the pre-processed titles, I get out a list, and you'll see that I've got 11 different clusters plus 12 miscellaneous, right? And in the House of Parliament, they vote for stuff like, when should the Christmas break start, right? And that's actually not useful information. We're going to get rid of that. And so again, we're just losing little bits of data along the way. We're hoping that it refines the signal and there's enough information left at the end. Okay, so that should be clustering done. Okay, classification. I vaguely remember what's on this slide. Okay, this is wild. But the classification task is basically that we need to identify, if we've got a division on immigration and borders, right? We've got the cluster. And I've got the vote, either for, against, or neutral, right? I could abstain from the vote, I could vote for the bill, or I could vote against the bill. I need to figure out if voting for that bill is going to positively or negatively impact my cluster, right? Is it going to, and if it's on immigration and borders, is it going to tighten immigration and borders, or is it going to soften immigration and borders? And we can call that sentiment, okay? And that sentiment, I want to know if it's one going to tighten or -1 going to loosen. And if I combine that with the vote data, and the product of those two will create like basically the classification. So this is where the meat and potatoes of the task goes, right? We got through the clustering task, but the classification is where it gets a little bit spicy. Give it a second. Okay, so if I'm going to classify these, right, I've got all these clusters that we found during the clustering process. I need to find opposing policy. And it's very easy for something like immigration and borders, because you can just have good or bad, tighten or loosen, right? Something like economy and financial services, everybody wants the economy to go up. Right? Nobody wants the economy to tank. So it's a little bit harder trying to find opposing policy positions. The approach that we took was to use the large language model itself to find these opposing policy. And the reason we're going to do that is twofold. First, I don't know anything about politics, right? Having a large language model come up with these is going to be, it's like having an expert. The second reason is that the model itself needs to be able to distinguish between what it's classifying, right? It's not enough for me to know the difference. If I'm going to use the model for the classification task, the model needs to know the difference between those two words. And the way you go about doing that is basically say, ChatGPT, I'm debating on economy and financial services. Give me one perspective on this issue. And you take that and you go, okay, ChatGPT, I'm debating on financial services and my perspective is stimulus in the free market. What might the opposing position be? And then it will come up with austerity and regulation. And you keep iteratively repeating that process until you find words that the model itself is very confident with. Okay, so that's how we got sort of the 1 and the 0 or the -1 position, and we're basically doing a binary classification between these two positions. We call this prompt engineering. It's where you're optimizing your prompts to get specific output. You're probably fully aware of this. In academia, the terms that they've come up with something called zero-shot chain of thought with document scan. Zero-shot means that I'm giving it 0 previous examples. Okay, I'm not going to give it some correctly classified stuff. I don't know how to classify it. But I'm going to give it 0 previous examples. The chain of thought simply means that I'm going to give the model time to think. Okay, and what that means is in the output, I want it to summarize the document. Right, it's 10,000 words. Summarize the document. I want it to give me arguments for, arguments against. Finally, I want you to give me a decision. Right, is this classification A or B? And the final letter of the output is going to be logically consistent with its prior output, right? So let me show you what that looks like. Yeah, so this is what it looks like. We're actually going to get rid of all of this information. It's not useful. This is all just used to improve the prompt itself. Something to notice is that would have taken me a week to come up with, and ChatGPT is going to come up with it in about 30 seconds. There's some inconsistency we can get into, but for now, all you need to know is that the only letter that matters in this output is the letter right at the end, and it's logically consistent with its prior analysis. Okay? Job done, I think. Hold on. Nice. Okay, so we got through it. We've done the classification, we've done the clustering. Now we can visualize the results and we can see what we can find. And at this point, a bit nervous because we don't know what we're going to find. But the first thing, if we group the data by Labour versus Conservative, and we display it in this radar chart, actually the first thing you notice is they're just different, right? You can see that Labour's shifted towards the left of the diagram. You see that Conservatives are shifted towards the right of the diagram, and they seem to sort of reflect and oppose each other. And okay, so that's an interesting. It sort of gives us a little bit of confidence in that the classification went well. We can also just split it over time. And what that reveals, right? If I split the time period and I plot the same graph over and over and see how it changes, you can see this sort of shift in the diagram, right? You can sort of see that Conservatives are more moderate, right? Slightly more rounded to begin with. But you see this shift towards the right of the diagram. And it becomes, by the end, it's actually quite polarized, okay? And you can do the same with Labour. And you see this sort of very rounded, actually a very moderate early diagram, right? That if you can imagine that the red ring around the outside means that I'm always voting for an issue. And then if the red ring in the middle means I always vote against, right? Whenever immigration comes up, I always vote for softer borders, okay? And actually you can see that Labour's fairly moderate, right? Voting either way. Towards the end of that diagram, that's simply not true. The other thing that we picked out is that you can sort of see reactions to contemporary events, right? You can see before the EU referendum, sort of Labour doesn't care, EU roughly good. After the EU referendum, we love the French, baguettes are great, I wish that we had more croissants, okay? So you see these spikes, and you can also see Partygate, right? And the reason Partygate's interesting is because Labour you'd expect to be softer on crime and punishment, but you can see this spike, and that is really where Labour are just trying to push Boris Johnson to be classified as a crime rather than as a misdemeanor. Okay, so that's cool. Sort of improving our confidence. If an image paints 1,000 words, then an animation is a whole book. So what I just want you to look at to begin with, right, is as this diagram resets, just watch the jump in shape that this takes place. I mean, it's fairly round. It's not round, but it's fairly rounded, and then it's shifting over time towards the right. One more time, we'll let that do the little jump. It's sort of shifting, and you can see this sort of environment and energy is very important to the Conservatives, but then ends up right on the inside, and they're always voting against it. We can do the same thing for Labour. I mean, Labour's really moderate, really centrist government, and then you see it's sort of this grotesque push, and it's sort of becoming a caricature of its own position, right? It's just very extreme in its values. Right? You see that jump at the end. Now, we're looking at this, and we're starting to think, okay, what is polarization? And in the paper, we make the claim that differences between diagrams, so the more different between groups your voting record looks, maybe that is a quantifiable measure of the level of polarization in the UK House of Commons based on their voting record. Okay, so we start to make that claim. And if you start to plot the values, in early 2006, you can sort of see, so -1 is always voting against, +1 is always voting for. Don't shoot me, but you could almost get away with saying that's sort of normally distributed, right? It's not. It's sort of bimodal with an anomaly in the middle, but the center of gravity is in the middle of that chart, right? By 2021, you can't call that normally distributed, right? It's bimodal, maybe trimodal distribution with weighting towards the outside, and the most extreme values on the end, so -1 and 1. There's a slight dip, so it's not a perfect inverse normal distribution, but you're starting to get there. And I'm getting all excited at this point. I'm thinking we could measure the amount of normal distribution and then plot it through time, and then we could say that that's have a statistical measure of the polarization. And then, quite rightly, it got pointed out to me that it's not normally distributed, and that's a really bad way of doing it. Relax. There's a way easier way of doing this. If you take the absolute value, right, so 1 and minus 1 of the extremes, you take the absolute value, right, it's centered around 0, then 1 becomes polarized in either direction, and 0 becomes more moderate. And we can just plot that across time, which is a way better way of doing it. And any minute, you'll see what it looks like. So yeah, so this is what I'm going to claim is a measure of polarization over time. And it's not a linear trend, but I don't think anybody would expect polarization, a social phenomenon, to be some kind of linear fashion. And you can see sort of in 2009, you have the financial crisis in 2008, you get this come-by-our moment where the Labour and Conservatives are trying to come together in a moment of national unity. But from that point on, there's clear polarization, right? Maybe the Lib Dems hang on for a little bit longer, trying to take a more moderate stance. But by 2023, you can clearly say that we are more polarized than we have ever been in the past two decades. Okay, so what's next? Since I've finished writing that with Stuart, I started an NGO called Open Parliament. The goal of that NGO is to help UK citizens make more informed decisions about who represents them in Parliament. Right, there's all of this data online. We've got the budget data I haven't even looked at, election data. You've got the data that I've already been working with. Can we visualize that for my nan, right? For my nan to be able to see it and make sense of it. So there's a lot of low-hanging fruit there that I feel like we should be able to pick. If that doesn't interest you and you don't want to help out there, fair enough. I can barely work on it at the moment with the new job. There's an alternative. There's something called the UK Democracy Forum, which is a loose collective of entrepreneurs and civil society activists, some of them from Europe, but a lot based in the UK. They're just sort of pro-democracy advocates, and they have a group chat called Air and Democracy, where people are just sharing papers and studies and findings that they're working on, which is sort of a softer entrance into that space. And then finally, there's another question, right? Is polarization actually a bad thing? In the UK, it kind of feels like it makes sense that polarization is a bad thing. But I don't actually know that that's true, right? If I go to China or Russia, you'd expect the amount of defection from the main party to be quite low, right? And so you'd expect the polarization to be quite low, but I don't think that would be necessarily a good thing. It might be that having real choice, giving a real choice between options, do we leave the EU or do we stay in the EU? Having a real choice for our populace is a good thing, and the more polarized, just having parties sorted along ideological difference is a good thing. We actually don't know from the data that I've just visualized. What we need to do is ground the findings today in a historical context. And the data's there all the way back to the 1900s easily. It just needs formatting, restructuring, and then fed through the same process. And if we can ground that in a historical context, then we could tell whether whether polarization is just a healthy part of a natural democracy, going through periods of polarization and then cycling back towards normalization, or whether we need to start ringing the alarm bells that actually this is a real problem. We've never been this polarized, and we need to do something about it. Okay, so that is more or less, I think that's me done. I do just want to say one more thing. I didn't get to say thank you to him at my graduation, so Stuart, thank you so much. I've never had someone just give me the space to play with ideas, and you had more confidence in me than I had in myself. So just, yeah, thank you so much for that. It meant a huge amount, and yeah, I appreciate it. So, thank you. Cool.
Any questions?
Yes.
How easy is to transfer this model?
So, great question. Question is, how does it compare to around the world? Can we map it to different political contexts? And you also mentioned political compass. I'm going to start with political compass. in the literature, they sort of don't believe in having high dimensional space, right? They compress the visualizations into left, right, and they're trying to maximize sort of the predictive power, right? Left, right, and then sometimes they do 4 dimensions to be authoritarian versus libertarian. And the idea is that actually you don't need to know. If I know you voted for immigration and borders, you also probably voted for stronger crime and justice. And so they maximize the predictive power. The reason why we try to avoid that is the explanatory power of having higher dimensionality is actually has some value, right? So that's why we differentiate slightly there. In terms of comparing with other states, absolutely. Like there isn't an easy way to measure polarization in a quantifiable method. The way that that's normally done is they look at sort of the language that's being used in the House of Commons. Having a quantifiable metric that isn't just language-based, like absolutely, we should be able to do that with any parliament around the world that has strong transparency initiatives. We can use that data and run it through the same process. The limit of that would be if it hasn't been digitalization or there's a lot of sort of black box style. Maybe you don't have access to the data, you don't have these big textual repositories, then it becomes a lot harder. But certainly in the US context, certainly in Europe, we can definitely compare sort of and see whether that pattern tracks and whether it goes in the same direction or whether we're going sort of different directions in the level of polarization. So yeah, it's something that I've been thinking about a lot. But yeah.
Another question.
Yes.
So,
the question is around avoiding misinformation from sources from which ChatGPT is trained on, roughly. And so, yes, there is some bias. Whenever I mention a specific bill, if it's a very controversial bill, it will be pulling in and mixing it with other stuff that it's trained on. I noticed that a little bit with sort of the classification. You might have something where I'm asking it to do a binary classification, but the reality is it's more complicated than that, right? In the short term, it might benefit the economy. In the long term, it's going to hinder the economy. How does it make a judgment call? And you do get, occasionally you get this switch between A and B. And ultimately, I think that just looks like noise on top of the data, right? If it can't figure it out, it's going to have some signal where it can classify easily, and it's going to have some where it fails. I tried several times to try and improve this. This prompt is basically a monster, right? I'm doing techniques like tagging the text, which nobody's really talking about. It's not really a technique. I've got this big document, and I want to make sure that it's pinning down exactly what I'm talking about, and it's not getting distracted too much. And so I'm highlighting the exact division. And if I don't do that, what I was finding was that the model was confusing the division with the bill, and then would classify the bill itself rather than the division. So there's loads of little, and just if you've got any questions, like I could send sort of the techniques that were being used, but like loads of little tweaks to try and improve that and optimize that output. There is failure. I know there's failure, but I think it happened at a low enough rate that sort of we got the signal that we needed, and I'm hoping that I sort of used the visualizations as evidence that actually there was some signal that made it through. Yeah.
A related question there. So, for these sort of techniques, I guess it's very hard to do any sort of methodological validation.
So questions about how do we sort of validate the accuracy of the classification? And that's right. In the paper, we're saying that actually this is almost pseudo-scientific approach, right? We're not using a traditional data science measure of accuracy. We don't have sort of false positives and things like that. How are we measuring the accuracy? And the reality is, I don't have the expertise to be able to classify this stuff myself. I could work through it, and I could spend the time trying to like piece together a subset of data and then test it against that and see what rate it is. It's not impossible. I personally didn't have the expertise to do it, and the size of the data set meant that like there was no way I was going to be able to do it like in the time frame. Yes, that's definitely a way to improve. And then, yeah, it's sort of, there were some things that we used to push evidence for it being highly accurate. And one of the reasons why we did that, if you look at something like immigration and borders, you get, for the Conservatives, almost 100% voting against immigration and borders. Now, if there was a high level of randomness in the classification task, it would be very difficult for it to get to 100% value. And so that's like a really cheeky, bad way of suggesting that there's a relatively low failure rate within the classification task. But that's outrageous, and I'm sorry that we don't have a better way of doing it.
Yeah, and it's sort of interesting, like how do you get a handle on these methods? But I mean, it looks like there's sensible stuff coming out, right?
Right, and that is a really bad way of saying you may be good. But yes.
Can I ask the question? Essentially, you're getting 12 categories here.
Yes. So I've clustered by immigration and borders, say. The clustering algorithm was done based on the title alone. Okay, the title is then fed in, but the title itself contains votes that actually do not link to immigration and borders. And so when I get to the stage here, it's actually not a binary classification. I'm allowing a C classification, right? So I've got based on the decision return either A or B. But I've also added a C classification, and a C classification is if there is a cluster. I've got this big load of text. If I've got a division that's on immigration and borders, but is more related to social housing and welfare, if it isn't related to tighter or softer immigration and borders, I gave it an out, which is just a C classification to disregard that. That again created noise because it wouldn't always classify it as C in that scenario. So the clustering is have a dash, get through it, and then the classification does a round of pruning to get rid of the worst of that. But again, if you try and get it to do that C classification, it wasn't doing it 100% of the time. And so there is definitely noise in the final result where some of the A and some of the B should be classified as C and not important.
So
If that makes sense.
that you decided that there are 11 categories.
Yes, and it's a trivial way of doing it.
So my question is there something Parliament does in that context?
No,
Not really.
no, and this is one of the things that just drives me mad.
Yeah,
Like,
I mean,
yeah.
or so for example, media, in a way.
Yes, I'm sure they do in some sense that there would be some community or civil rights group that are clustering by something, but the actual data set itself is so thin. They're not doing any processing on top of it. They're just giving it a title and they're giving me the text. That's it. So the idea, like even putting a label on this, is a step in the right direction. So yeah.
Even so, just to kind of because in a sense you could almost use that feedback because politicians are listening, MPs are listening.
Mm-hmm.
They might read the title of a bill, but actually, they have some people who read it for them, and they might give them some sort of this is the immigration and borders bill.
Yes.
You should vote X, Y, Z.
Yes.
I guess that already might introduce some sort of bias actually on their side rather than on your side.
And the only other part worth mentioning that's sort of related to that is that a lot of political scientists that sort of I was speaking to were saying that actually the vote profiles of MPs is a really bad way. We don't like to use that. And the reason they don't like to use that is because there's a lot of party political bias. There's a lot the party whip. If you don't vote on this way on this bill, we will take away the whip. We will remove you from the party. So they create a lot of bias, and that ends up looking like signal. But I mean, even if the finding was the power of the whip in UK politics has grown significantly over the last 10 years, that's still a relevant finding that I would consider sort of important. Does that make sense? Any more? Yeah.
I was just wondering because I don't know if this is a big question, but you said about like local people, like not knowing who their MP is, like how would this help with specifically like understanding how your local representative represents you more over like just the general party view?
Yes, very cool. I did this for every MP. So I've done it, broken it down by individual MP as well as Labour Party and constituent. The reason why I've avoided putting individual MPs in the paper and in the presentation, so to remove the like bias part, I think if you looked at some of the like Boris Johnson or you looked at Jeremy Corbyn, there actually are really interesting observations in there. Jeremy Corbyn was an example pointed out by one of Stuart's colleagues. He's known for voting with the Conservatives, rebelling against his party on certain issues, right? Because he's very opinionated. His diagram ended up looking more extreme than his Labour peers, and the reason is because basically every time the immigration and borders came up, he would not only vote to soften immigration and borders with Labour, but he'd also vote to soften it with Conservatives, and that results in a more extreme diagram. And so, at a party level, there's not much information for like myself to look at. Who's like, what does my MP vote on? But if I looked at the individual MP stance, I could get like John Redwood would be my local MP for ages now. It's forgotten his name, which is outrageous, considering the talk. But yeah, you can break it down by individual MP, which might help. Cool. Any more? Yeah.
Yeah. So building on Mark's question, I guess, and your response to bias, I was wondering if you could tell us more about how you deal with abstentions, because an abstention when you're the majority party might actually be a no vote, really.
Yes.
You don't want to get in trouble.
That's exactly right. Yes. In this methodology, I figured out that it's really hard to figure that, like, actually factor that in. I'm taking the value as you've got the sentiment. It's either positive or negative, 1 or -1. And then the vote profile, I'm saying if you voted for, that's 1. If you voted against, that's -1. If you abstained, I'm just calling it 0. And I'm taking the product. And so these diagrams do not record abstention. And that is definitely a way to improve. There's so much useful information in abstention. The real problem with that is that abstention is not, you can't differentiate between abstention and absence.
Yeah.
And so if 20 MPs turn up to vote on an issue, suddenly I've got 500 people that I don't know if they abstained deliberately and there's some signal in there, or they just didn't turn up and they're absent, right? And so it's very complicated to try and you could figure it out based on the number of MPs that voted, I guess. But I mean, it just becomes. I was like, I'm not going to solve that problem. Somebody else can solve that. And so I just called it 0 and removed it from the data, unfortunately. But yes, very good spot. Any more?
Thank you.
Cool. Thank you very much, guys. Cheers.